Hi and welcome to this unofficial ad hoc run through of what the Uleska system does. Now, to sign up to the Uleska system on our cloud, you can go through the social logins. We have Keycloak there and we can turn on some other social logins if necessary. To sign up with those, you can create an account and go through that. Depending on the social login, I'll take you through a wizard, which can then add in some of your repos if that's what you request to do. But we already have an account and we're going to use that. So actually I'm going to use my social login. So I already have a GitHub account in this system. If I click on GitHub, that will sign me in. So I already have a number of systems and projects set up here. Just to go through, whenever you log in, you can see a certain number of projects. The number of projects you can see will depend on your user access and depend on your level of the team you're in. So if I just go to Uleska documentation, if you look for teams, there's a whole description here about the way Uleska has their team set up, the tree style structure, and the types of users that we have. Right now, this is logged in as what's called a customer admin, so I can see all the projects and I can use all the functionality. Each project, it depends how you wish to use this here, but each project can have multiple versions or subcomponents listed here. For each of those, you'll be able to see the results and run tests against those individual subcomponents. So if you have different repos or different microservices, if you want to separate out containers, and dynamic testing and IAC testing, etc., you can do that all under the overall application layer, if that's what you wish to do. So what we're going to do is just show an example of adding in a new application. I'm going to call it Gary's app. Description, this is my app. Now there is some information here you can list out which helps the Uleska system determine the overall risk of vulnerabilities come at it, because if you have an SQL injection that affects 100 users versus 1 million users, that's going to be a higher risk level of issue. Also some information here, and this is all used for the fair risk algorithms that we do. You can also specify what team you want the project to be running in. So we have our Gary app now added. That's just a holder to allow us to be able to run some testing. So I'm going to add a version in here, and this is going to be a code repo that we want to be testing against. So version number 1, this could be a tag, this could be whatever you want it to be. And there's different setup depending on how you want to do dynamic testing. You can also save this into containers, etc. What we're going to do is we're going to set up a code repo. Now, code repos can either be specified via a Git address, or you can upload zip files. And we have helper scripts if you're doing this through your command line or CI/CD to be able to upload any of the scripts. So we're going to take a Git address. I'm going to take something that is fairly vulnerable, like unsafe bank. I'm going to take that repo and add it into Uleska. Now, depending on whether the system is authenticated or not, you can test that. Here we have the ability to access this without typing any authentication. You can pass in username, password, SSH key. You can even specify a particular branch, and this is all documented in our documentation. But we have this now set up, so we're going to add this version. At this point, it's saying if we wanted to add any containers, we could. There's also certain other levels of things we can do to specify the JIRA. This would update upon tests, PDF reports, other information like that, but the documentation is in there in the background to show you how to use that. So we have Gary app and we have our version 1 that I'm going to run against. Now at this point, through the UI or through our API or command line interface that we'll show later, you can run tests. But what are these tests? At this point, we'll go to what we have is called toolkits. Now in the Uleska system, we have a number of adapters for different tools that can be run against particular projects, and they can be SAST, DAST, IAC, cloud checks, CIS checks, all that type of stuff. And what we do is the Uleska system brings those different adapters together. You can add new adapters through our custom tool interface and look on our YouTube for the videos to how to create a custom tool. But essentially what you do is you're able to create a toolkit, and I'm just going to show this here. Whenever you're having the toolkits, you can specify what adapters, what tools you want to run. Here we're running Chekhov, we're running dependency checker, we're running Node.js scan, we're running semgrep in certain ways. And that can then be set up to have what we call as a pattern, because when you have these different toolkits, you can specify, oh, Team A would make sense to run this toolkit because they're working in Java and they have Dockers. Team C would be better in this toolkit, and allows the developers or the development teams to be able to run a standard set of testing, including the tools and the profile configuration for those tools, a lot easier because they have a single command line to do that, or one hook in their CI/CD. But at the same time, the security teams are able to help set up those security profiles or those security toolkits to be the most efficient. So they're not randomly creating all the false positives or all the nonsense issues for a project that's not going to appreciate that. They can help narrow that down. Again, we have webinars and documentation on our various toolkits if you need more information. So we have our Gary app. Whoops, just moved on me. Let's run some testing. Let's run it through our standard set of code. As you see here, this then is going to specify 5 tools it's going to run. Let's start our scan. Again, that exact same thing can be done via our API and via our command line interface, Uleska Automate. And what this is going to do in the background is it's going to collect the information it needs. It's going to spin up with our Dockers and our Kubernetes infrastructure. It's going to spin up the relevant Dockers it needs to actually run those security tool adapters. So it will run a semgrep in a Docker. It will run a bandit or whatever that's going to be in a Docker. Or if there's commercial tools that you have running in the cloud or in your environment, the Docker will actually spin up an API client to communicate with that security tool and bring the results back. All with the aim of having those results collected into one place in a normalized way that you can then apply other security jobs to it. For example, determining the risk, working out false positives and duplicates, bringing the information together, understanding what the changes were from the last time you did your security scans. And this makes it a lot easier then for security team or development teams to run their own testing, or for this to hook into CI/CD and be able to let you know what's happening before you release. So what this is doing in the background is it's spinning up and orchestrating the Dockers that it needs. The Uleska system has a mechanism in the background to be able to spin up the number of Dockers it's allowed to with the infrastructure is there to manage the jobs that are coming in and coming out, and to suck all the results together into one place for that project, for Gary app, for version 1, so it can then allow you to do jobs on top of that. In the background, it's also, as you see this green ticks, it's monitoring that those jobs have succeeded. For example, some jobs may fail if there's a problem with the tool itself or the adapter, if it can't access a certain cloud resource, or if it can't access the code, etc. These are reasons why a certain test or test execution could fail. Now, if that happens, the Uleska system will reply with that, both to the UI and the API, by giving information, or in the UI gives a red X, and lets you know that some of the tests fail. Now also, if you try to run a range of tests when you don't have the configuration there, so for example, if in that particular test I had tried to run a DAS test, it would have flagged up immediately that I hadn't put in a URL for the dynamic test to run against, and it would have specified that it's not going to run that dynamic tool. Similarly, at the end, it would have specified that it only ran 4 out of the 5 tools because the dynamic tool did not run. And that lets you then understand, as this scales out, what tools are being executed, and are you able to compare like for like, because you don't want to pretend that all your DAST issues have suddenly been fixed. It doesn't consider that. It considers those that haven't been run. So we'll just let this test run. As you can see, this interface shows a lot of different projects that have been added in. These projects can be added in via the UI, they can be added in via the CLI or the API as well. And there are companies that have developed portals to allow development teams to onboard their applications here as well. So we'll just let that continue running. What I can maybe do in the meantime, I know I'll actually, pardon me, I'll wait for this to finish. Whenever a test is run, it gets categorized as what we call a report. So if I show, for example, some other results here and go to other results. you'll see that the different times this has been run has been recorded in the background, and you can actually go to previous runs and see what the issues are. And as you can see here, the number of different vulnerabilities. So all the vulnerabilities are brought together in one place, you know, organized by title, by the amount of risk, etc., and all the good stuff. You can also apply invalid vulnerabilities that we haven't here, but we'll show that in a second. And this can then be extracted again via our API, via our CLI, so you can see all the results of a particular scan against a project. So going back to your app, still just waiting for some of those tests to finish. In the meantime, then what I'll also show is some of the financials and the applications. So you're able to take your various applications, like Gary app we just added there, and you can categorize those into whatever sort of tree level determination you wish to use for your organization. So into different teams or different divisions, etc. And Uleska then will take those stats, the number of issues, the level of risk, etc., and it will categorize that into some of these tables. So if you have different divisions, you can see over time, how are they improving or how are they getting on. You can also, for some of them, you can see the different graph trends over the past while and compare and contrast the average risk for the projects, the number of vulnerabilities, and that sort of thing. We also have Analytics tab, which shows slightly different information. For the overall organization, you know, what's the level of risk, how's that going up and down, how does it look in terms of vulnerabilities and number of applications. As we see, we've just added one here, and we're going to have some new vulnerabilities added in. You can categorize your different issues. So the Uleska system allows you to see a vulnerability. If it's already categorized against an ASVS category, that will be remembered, and the Uleska system will continue to report that. If it hasn't been categorized, so if you're getting a certain issue back from SEMGREP or from Burp Suite or whatever, it will allow you to categorize those for your own organization, and it will be sticky. It will remember that. So then it can have a way of giving you these donut charts to let you see where your main levels of risk are coming from, and that allows you to inform your strategy and continuous improvement to make your security systems better. So we'll just go back and see if this is finished yet. No, still not finished yet. I could stop it if I want, but I want this to just finish its level of tests. Whenever it does give the results, they'll all be listed here. As you can see a sort of snapshot of what's already been returned, but we want it to return all the vulnerabilities when that's finished. So again, in the meantime, what I'll do is I'll just mention the custom tools here. This is an interface where you can add in new tools. Essentially, a custom tool in Uleska is a Docker that gets added into the system and run as part of Kubernetes. There are mechanisms in Uleska, the platform, that gives the Docker information, such as where the code repo is, or the dynamic system to be tested, or the container, information about the project name, etc., or certain tool configuration. It then executes a certain command on the Docker, which will be the actual tool to check. So that might be a wrapper around SEMGREP. It might be an API that goes out to JFrog or whatever else to be able to either run testing there or suck the results back. And then it has a mechanism by which it can take programmatically within the Docker all the vulnerabilities that have been discovered, put them into our taxonomy, write them actually to an XML file, which then gets passed back to the Uleska sort of mothership to be able to be included with all the rest of the vulnerabilities that were returned by the other tools. Okay, so that's still running. So what I'll do here is briefly then go to the account and show you that. So with the Uleska system, this is hooked up to Keycloak. It can be wrapped into our SaaS or brought into an organization's own environment, as Keycloak can be wrapped in. People can change their emails, they can change the passwords, etc. There's an API token, which is then used for anybody using the command line interface or trying to use the API. And for anybody on the PLG, they can see when their license is going to renew, how many credits they have, charges, and they can upgrade their plan if needed. So again, that's just running for a bit. What I'll do is I'll then show the permissions. So the Uleska system allows you to invite new users through email address, give them a certain permission level of Customer administrator, that's the widest level of use. Application managers, who are then allocated to a certain teams and can only see the projects that are relevant to their teams. So it means you have various teams amongst your organization. Somebody in team A can't see or run tests against projects in teams B, C, D. Allows you a bit of segregation. It also means somebody, a developer logging in or working on the system, doesn't see thousands of applications. They only see the ones that are relevant to them. The executive can only see the statistics. And as I say, then the customer administrator is pretty much like an admin user, can see everything. Whenever you have people, they can be then assigned to what we call teams. Also, so can projects. So the Gary user, or the Gary app, was actually added to the Belfast team here whenever I created it. And that just means as a categorization for it, means users within the Belfast team will be able to see the Gary app instead of people in Atlanta and Amsterdam who aren't working on that project. And teams can be modified. Users can be moved amongst different teams. Users can exist in multiple teams if that's where they need to have visibility. Projects can only exist in one team, but the tree style structure allows anybody who's in a more senior team, they can see all the projects and all teams below them. And that's a nice way of being able to categorize the different projects across your organization. Okay, so the Gary app has finished running, and there's a bunch of issues that have been shown. So we have them here. Now, this is the very first time this has been run. So as with any open source tools, no matter what way you do, you can configure your profiles, etc. There's going to be certain non-issues. There's going to be certain false positives. There's going to be certain things that you might want to change. And you can view all the information, or some of the information here, in terms of the full detail. For any of these issues, you can actually modify it and let the Uleska system learn what you care about here. So for example, let's say this issue comes up, ensure that copy is used instead of AGD in Docker files. So what we're going to do is we're going to make a modification here, probably as a security user. And I'm going to say, I want to set an ASVS category for this. So let's just search for Docker. No, let's search for least privilege. Okay. So I'm going to make sure that everything has the least privilege, and I'm going to say that's the ASVS category for this particular issue. And as far as CVSS, I'm going to set a CVSS to associate with this type of issue being returned from SEMGREP. So it's, say, adjacent, it's a low attack complexity, you do require privileges, the user doesn't interact, the scope is changed, confidential integrity is low, but the availability is none. In fact, that should probably be low just for the sake of it. So that's then going to record this CVSS. I'm going to press back. Now, as I press save here, then this means that any time from now on that SEMGREP returns this particular issue, that's going to be remembered in the system. And that's the way the Uleska system learns as time goes on what you as an organization require for each the categorization of each of these types of issues. And we see here that's been listed, and that'll again go back to the various statistics and metrics and analytics that we have. So let's say there's another type of issue. Let's say ensure that the user for the container has been created. Let's say we just don't care about that. We want to let's take another issue here, the potentially invalid file. So it's saying that there's a DB-SQL file there. It's saying it's an issue. Let's say we don't think that's an issue. What we can do is we can go into our operations here and enter that as a false positive. So we can say set as false positive and exit. Now what that then means is that issue inside the Uleska database is categorized as an invalid vulnerability. And this is where you can put your duplicates, your non-issues, your false positives, etc. And what that means is the next time we run this scan with the same set of tools, we imagine that because we consider this is not a false positive, we're not going to fix it, and the tool is still going to return that issue as something that needs to get fixed. But what the Uleska system does is it intercepts that, realizes that particular issue previously was set as a false positive, and it will reset it as a false positive. And as you can imagine then, once you've done your triage and you've gone from, basically removed a lot of issues, this invalid vulnerabilities list becomes quite large, and is a way of storing state of the things that are returned by tools, but you consider a non-issue. And they're then not reported in the PDF reports, not reported statistics, not given back to developers, and not used in the delta triages between, you know, what was scanned before and what has been scanned this time. And that really makes them much more efficient to be able to run quick security checks during development and during CI/CD. So this report will be the only one listed here, but if for audit later on we want to look back and look at different reports, we can do that there, and we can even print them out. So at any time you can see logs of the testing that occurred. This is output from the Kubernetes. And see that if anything goes wrong or you're not sure, you can go in there and check. Otherwise, you can actually output this information as CSV or as a PDF. So there are certain things on the project you can use to set a cover screen here and covers and etc. But this allows you then to generate what the actual vulnerability is and have that printed out. So we'll see also that right now all of these are categorized as no risk. If we go to another project, we can see one which does have the risk in it. So the risk value here is determined based on an implementation of the FAIR algorithm that Uleska has within it. So without getting into full detail, it has a way of calculating the various costs that come towards the project. That's really based on three categories. One, the CVSS, which talks about the technicality of the issue, how it affects availability, integrity, confidentiality, what's the scope of the project, how easy it is to do the bug, do the exploit, etc. On top of that, it also includes then information about the project. So what is the number of users, what's the downtime, is it an internal system or not, what's the restoration cost, etc. And as you can imagine then, if you increase the number of users, if you increase the potential criticality or downtime cost of the project, that will increase the subsequent FAIR risk for all of these projects, for that particular project, apologies. And the last one is you can set inside the project what type of data, financial, healthcare, PII, etc. And that then again allows you to know that there is a technical SQL injection that would affect PII in a project that is external and has 1 million users. This is then all used to be able to put together a risk estimation for those projects and for those issues. And that allows you to prioritize what types of issues you need to be working on. Because again, if you've got a SQL injection that's going to affect 30 million people, or another SQL injection that's going to affect 3 people and no sensitive information, you need to put your resources on the higher risk. Now, right now, this presents dollar values. This is how we built the Uleska system. We have a plan, or had a plan, to be able to convert that into another form of red, amber, green, high, medium, low, number between 1 and 1,000, just to better represent the risk, as some organizations don't like passing around risk in dollar values. So that gives you a high-level overview of the Uleska system. It is a API-first system. Everything you see there can be done via the API. And if there are examples of using our API on the system, but if I go here to, I don't have the depth. So if I go to our Uleska Automate, this will show an example, because this is our CLI, Uleska Automate. It's available as a pip download to be able to test with, and essentially has a number of arguments to allow you to wrap this type of testing either into a developer's own command line use. In fact, with the ability to put in like configuration files, you can actually just have this as a one-word, one-line command that can then be used to test the current project. Or you can wrap this into your CI/CD. As we see here, there's different ways of specifying what application you're testing against, even update the repo you're testing against, etc., update the container. But also what you can do is print the results in different ways. So for example, you can run the CLI either in CI/CD or against whatever command line. You can run it in blocking or non-blocking mode. So it can start off as the testing of Uleska, but then the CI/CD can go off and continue with the rest of the builds and packaging. Then later point you can check in with Uleska, see that testing is finished and understand what the results were. Or you can run it in blocking mode and wait for the results to come through. Whenever you're looking at those results, there's different ways you can do it. So you can either see all the results, all 30, 300, whatever the results are going to be, as well as the overall risk and the overall CVSS scores, etc. or what you can do is compare latest results. So what that says is, previously we ran a scan against this project with a certain toolkit, set of tools, and it returned, for example, 30 issues. Now we've made changes this week, this project, we want to run the testing again, and we want to understand just what's the difference. So do we still have 30 issues? Are they still the same 30 issues? Maybe 2 have been fixed, 2 have been added. Maybe we've got 32 issues now, in which case we understand what's the CVSS of those, what's the description, what's the risk of those, and maybe we've actually got 28 issues now, so we know the risk has reduced by a certain level. And you can then programmatically decide, well, we will allow the build to continue without any intervention if the risk increases by less than 5-10%. You can have the sort of controls. If we have a CVSS new that is above a 6, we're going to have some intervention in the build, or we're going to fill the build, whatever way you wish to do that. And they can all be done by these flags as well. Feel if risk is over, feel if the risk changes over, feel if we find an issue, a new issue, which is a CVSS, over a certain value. And that allows you then to automate a lot of these steps in the CI/CD process, so that the intervention can only be taken if and when it's needed. So there are videos on the Uleska YouTube account that will show you the CI/CD running and the various options there. But if you have more interest in knowing more about how this all works, please contact myself. Okay, thank you very much.